Yes. Members.
Yes,
Yes,
teacher.
sir.
Are you seeing what
Teacher.
I'm sharing the screen? Are you seeing the work on the screen?
Yes.
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 I believe you are seeing my notice board and then the notes. Are you seeing both? Are you seeing all of them?
Yes.
Yes.
Very good. Yes, good afternoon once again.
Good
Good
afternoon.
afternoon, teacher.
How are we?
Good
We are
afternoon.
fine.
We are fine.
All right. We can't wait now for others. I'm seeing let's continue with those one who have joined. Okay. Those one
Yes.
who will come late, they will find us on their way. Okay.
Yes.
So where did we stop? Where did we stop at that time? We finished the whole concept of function. Now we are left with only one. We are left with only one part of function, that is the composite function. Okay.
Yes.
So composite function, our heading for today, right? Composite function.
Functions.
Composite functions. I believe what I'm writing on the screen is clear.
Yes.
Yes, composite functions. That's our heading for today. So when you look at what I have in the note, I said a composite function is a function which is composed of a function of, which is composed of a simple functions, which is composed of a simple functions. Are we together? Members, are we together?
Yes, teacher.
Yes, teacher.
Yes.
Yes, teacher.
So when we get 2 or 3 functions and we put them together, combining them together is what we call, or if you don't want to use the word composite, you can use combined function. It still means the same thing. Composite means combining something together. Okay.
Yes.
Yes. So when you combine 2 functions together, we combine simple functions. Simple functions, they're like the one we have looked at. We said we have very many letters. The common letters, common letters used for function. We have h of x, f of x,
F of X, G of X.
g of x.
Yes.
Yeah. We can even have k of x. We can use any letter of our choice. Okay.
Yes.
So we can use letter of any of our choice. We can use h of x, f of x, g of x, and then k of x. So it depends any. So when we get these 2 functions and we combine them together, it will form as what we call a composite function. Like we can look at, if I have, for example, if I'm taking consider 2 functions. Consider 2 functions, f of x, and g of x. Okay. If you take, for example, if you have f of x and g of x. Okay. If I combine them together to form a composite function, then it will be written as f g of x. So this is what we call a composite function. This is composite function, but it's a composite function of f and g. But the function is defined by x. Is defining x. Okay. So now when you look at it, for example, in the notes, for example, the function f g of x, we read it as f g of x or f g mapping x. Okay, where f and g are functions known as the combined one. When we combine them together, now we said it's called a composite. It's called a composite function. It will become a composite function. The results is the image of x. Okay, the result is the is the image of X, unconditionally followed by F. So when I have F G of X, okay? So this is what we call a composite function. So it's all the image, what the results that we get is a combined image of F and a G. Okay?
Yes.
So now when I give you two functions, take for example, let's look at that example now. We know what composite functions are. Let's look at that example. I'm saying if we have example number one, let's look at example number one. I have f of x equals to x squared and g of x equals to x plus 1. Okay, these are simple functions. F and g are simple functions. Now they want us to find Roman 1, find g f of x. Find f g of x. Now, if you want to find that function, if you want to find the composite function of these two functions, we are going to say, remember, you have first to know the function of f g, you have to know the function of g. Okay? There's something I want us to investigate here. So g f of x. Now, if you want to get the composite the combined function or the composite function defining x, we are going to say, this is how we write it, so it implies now. We first take the function which is close to x. And the function which is close to x, which one is that? Is f, not so? Is f. Are we together? The function that is close to x is f. So you can see from there. So we are going to write it as f g of x will be equals to g. So I first open a bracket there, f g of x, close that. So let's see how I'm writing it.
Yes.
Yes. So we first take the function which is close to x, which is when I write like this now, then after that we ask ourselves g into what is the function f of x. F of x was given to be x squared. So you replace the x squared, you replace it there like that. You replace it there like that. Is it clear now?
Yes.
Yes. Now, after replacing that, now this x squared, now it becomes a single function of x. Okay, it becomes a single function of x. Now you have to go back. You go back where? You go back where there's what? X squared. Where there's g of x. Are you seeing where g of x? G of x was given as x squared plus 1. So now, which means x squared become a single value. X squared become a single value. So you have to, where there's x now, you replace it with x squared in g of x. So when you substitute that, you will get our x is now x squared. So it will become x squared plus 1. Are you seeing that? Have you seen that? So which means the composite function now, g f of x become x squared plus 1. As simple as that. Is it clear?
Yes. Yes.
Good.
Yes.
Now, after getting the composite function now, then we can go ahead and now find what? Roman 2, which was asking for. Let me take you back there. Roman 2 is asking for g f of 3. Remember now we have already got, you have first to get the function. The function, we have already got the function also. What is the function? The function is g f of x, which we have got, which is x squared plus 1. Now they want us to find g f of 3. Now, which means x is already 3. So which means where there is x, we shall replace it with the 3. Right together. Yeah. So when you substitute, when you substitute that, we shall have f g of 3 will be equals to x, which is 3 squared plus 1. I think what's on the screen?
Yes.
So 3 squared, we get what? 9. 9 plus 1, what do we get? So our f,
10.
of 3 is what?
10.
10.
Is it 10? Are we together on that? Are you seeing how we form a composite function? Have you seen how we form a
Yes.
composite? Is that side clear?
Yes.
Good. Now, the B part. Let's go to the B part. Are you seeing the B part? Example. There's something I want us to discover. I want us to discover by ourselves from that two examples. Can we go to B? That was A. B. In B, what do they want us to find? They want us to find F G of X. They are not the same. The other one was GF. Now this one is the FG. Okay?
Yes.
Now, which function is close to X? Is it F or G? Which
G.
function?
G.
Is G. So which means now when we are writing it, it becomes FG of X is equals to F. We open that bracket, then we put G of X like that. Are you seeing that?
Yes.
Good. After that, now F into, then you ask yourself, what is G of X? What is G of X? What is G of X?
G of
X squared plus 1.
G of X, not G of, is G of X. G of X is X plus 1, not so.
X plus 1.
Yes, it's X plus 1. So it becomes like that. Are you seeing that?
Yes.
Yes.
Now, I say now X plus 1 become a single value. It become a single value of X. Assume it, take it to be a single value of X. Okay?
Yes.
Yes.
Now, after that, so now we shall have FG of X equals to, now, are you seeing where is F? What is our F? What is our F of X? Is X squared, not so?
X squared.
Yes.
Now I will take X plus 1 as a single function, and then I will put it there where there's X squared, which means it become X plus 1, but what?
Plus 1. X squared.
But squared. Are you seeing that?
Yes.
Yes. So can you expand for me that? You expand for me that. That is a factorization. We have looked at that one when I look at factorization. Can you expand for me that? What does that one mean?
Can be.
What does that one mean? It means we have to multiply the brackets how many times?
2 times.
2 times.
2 times. Side work. That is our side work. Okay?
Yes.
Side work. So we shall have X plus 1 squared equals to X plus 1 into X plus 1. Is that okay?
Yes.
Yes.
So which means X, it will be the same as X. Those who have forgotten how to expand, so it will be the same as X into X plus 1, not so? Plus 1 into X plus 1. Are you seeing that? So
Yes.
when you open the first bracket, X times X will give us,
Yes.
X times X will give us
X squared.
X
X
squared.
squared.
X squared. Then X times 1,
2x.
X.
X.
it will give us X plus, then the second bracket, X, 1 times X
X.
plus
X.
1,
X.
1 times 1
Plus 1.
plus 1.
1.
So you can see that this one, they are the same. We can add them together. You see what I've circled there?
Yes.
They are the same. They can be added. So we shall have X squared plus X plus X,
2X.
2X plus 1. So which means when you expand X squared plus 1, I mean X plus 1 squared, you get X squared plus 2X plus 1. So what does that one mean? So it means now, I've turned the page.
Yes.
So it implies now our FG of X is now going to, which was, we got X plus 1 squared. Okay? Not so?
Yes.
Yes.
After expanding, what did we get? So therefore, FG of X is equals to X squared plus 2X plus
2X
1.
plus-
Plus 1. That is after expanding, not so?
Yes.
Are we together?
Yes.
Now, after that, they also want to us to find G of X when X is equal to 3. So Roman 2, they want us to find FG of 3. Are you seeing that?
Yes.
Yes.
So we have to substitute 3 in the function. The function was, what is the function? FG of X, be smart in your work. FG of X equals to X squared plus 2x plus 1. Okay. So now we have,
Yes.
so we have to substitute now. X is now what? X is 3. Okay.
3,
So when you substitute that, you shall have 3 squared
3
plus
squared.
2 times
2
2 times 3
3
plus
plus
1.
1 plus 1.
What is 3 squared?
9.
9,
We get 9 plus
6,
6.
plus
1.
1.
1. 9 plus 6,
15.
15 plus 1,
16.
16.
16.
With those two examples, what have you discovered? Who can tell us what have you discovered in these two examples we have done? When you look at the first one, which was when you look at df of x, not so, and fg of x, what have you discovered? Are they the same?
No.
No.
So what does it mean now? What does it mean? What does it mean? So it implies now, members. Hello?
Yes. Yes.
Yes, teacher.
Now it implies that Come on. So it implies that, okay,
Yes.
f g of 3, okay,
Yes.
is not equals to, I think that symbol is not equals to g f
GF
of 3. Though they were the same function, but they are not the same. I think that.
Yes.
Yes. Now, to make it the same, that one will now take us to what we call conditional functions. We call it conditional
Function.
function. But now we have seen, when you see, tomorrow I may say now, solve. Let's say solve. Okay. I'm adding a question on that. Solve. Okay. Solve. Or let me say find, solve for x. Solve for x. I think what I'm writing?
Yes. No.
Yes.
Yes, solve for x when or if fg of x is equals to df of x. Have you seen that question?
Yes.
Yes.
Now this is what we call conditional function. This is what we call what? Conditional function. But we have discovered when we were doing the example, we saw that they were not the same. Were they the same?
No.
No. But now if I want to make them to be the same, I have to put a condition. So that's the condition I've said. I think that.
Yes.
So can we find the value of x now? Solve for x when that one function is equals to that. So we know that. Recall. Recall. What was our fg of x? What was our what was that function? We got what? It was x squared, not so?
X squared
Plus 2x
plus 2x plus 1.
1. Then what was our gf of x? What did we get? What was it?
X squared.
X plus X1 squared.
X squared plus
1.
plus 1. Now they've given us a condition that for us to find x, these two functions must be equal, not so?
Yes.
Yes. So can we substitute? So it implies now. Fg of x equals to df of x, which will give us now x squared plus 2x plus 1, not so? Must be equals to x squared plus 1. That's the linear equation. So what do? We collect the light terms. We collect the light what?
Terms.
So when you look at x squared, we have x squared on the left, then x squared also on the right. Not so.
Yes.
So what will happen? This x squared will cancel that x squared. Not so?
Yes.
Then we remain with 2x plus 1 equals to 1. Not so?
Yes.
Continue collecting later term. So we shall have 2x is equals to 1 minus 1. Not so?
Yes.
So 2x is equals to 1 minus 1, we get 0. Not so?
Yes.
Yes.
So if 2x is equals to 0, are we looking for 2x or we are looking for x?
For x,
For X.
So what do we do?
divide both sides.
So x
Divide
is
both sides by 2.
now
Equal
remember.
to 0.
Now remember, at the other time I was talking about conditional what? I've talked about conditional function. Then we have talked about undefined function. Undefined, okay?
Yes.
When do we say that a function is undefined? When the denominator is 0, not so?
0. It's meaningless.
Yes, it's meaningless. So 0, what is 0 divided by 2? Is it meaningless or the answer is there?
0.
So
0. Meaningless.
0.
is 0, okay?
Yes.
So which means for these two functions, now they're telling us that for these two functions to be equal, x must be
0.
x must be 0. Otherwise, they cannot be equals to 0. Are you together?
Yes.
Yes. Is it clear? Any questions so far? Any questions so far?
No.
No.
Very good. Let me hope everyone is writing.
Yes.
Yes.
All right. So now, are you seeing that notes there where I'm saying composite function linked with matrices? Are you seeing that one?
Yes.
Yes. That one I've already even explained it. Are you seeing what I was talking about? I said fg of x is not equals to g f of x. That one we have already explained it. Not so.
Yes.
That one we have already explained it. It's very loud and it's very clear there. It's very clear there. So can we move to the next example now?
Yes.
All right. The example is there. Can you write it down? Write it down. Write it down.
Teacher, I'm not seeing.
You're not seeing the example. The question is there. The question is there. The question is on your
We
screen.
are seeing.
Yes, it's on your screen. That
Is it on the left side or the right?
Is on.
On the left.
I'm not seeing it. I'm not joking, actually.
Hey, who is that one?
It's not looking.
Now looking.
Yes.
Are you seeing it now?
No.
Okay. But are you seeing the screen? Are you seeing the screen? You are seeing what I'm
Yes.
writing. You are seeing what I'm writing.
Yes.
Then how comes that you are not seeing the notes?
Until the paper is blank.
The notes is this side. Is this side.
The only thing I'm seeing is 2x plus 1.
Hey, you are not seeing f of x.
I'm not seeing.
Okay, now you see what I'm writing on the screen. The question was, two functions, the function f and the g are defined by, we have f of x equals to 8 over x minus 1. Okay?
Yes.
And then, and g of x, is 2x plus 1. Are we together? Are we there?
Yes.
But now in f of x, they told us very clearly that for this function to exist, okay, or for it not to be defined, to be undefined, x must not be equals to 1. Who can explain why we are saying that x should not be equals to 1? Who can explain that? In f of x. f of x equals to 8 over x minus 1. But for this function to exist, x must not be equals to 1. Because when you substitute, when x is
Teacher,
1,
can I try?
yes, please.
If it is 1, we shall get 0, and it will be undefined.
Excellent. Good. Members, the rest, are we together?
Yes.
Yes.
Good. Let's go to part A. So they want us to find f g of x. They want us to find f g of
X.
x. So what do we do? We said f g of x, okay, is equals to f. We take the function which is close to x, which is g of x. Not so?
Yes.
Like that. Then f into what is g of x? What is g of x?
X. 2x.
2x plus 1.
2x plus 1. Now we take it as a single function. We take it as a single what?
Function.
Function. So it implies now f g of x will be equals to, now what is it? F is what? Is 8 over x
8.
minus 1, not so? So which means I'll have
Yes.
8 over, where there is x, now we replace it with it. We replace it with
2x
2x
plus
plus
1.
1. So we shall have 2x plus 1, okay? Then minus 1.
1.
I think that one.
Yes.
Yes.
Can we simplify it further? So we shall have 8 into 2x plus 1 minus 1. Not so?
Yes.
1 minus 1 will cancel out. Then we remain with 8 over
2x.
8 over 2x.
2x.
But I think common factor, I see there's common factor there, not so?
Yes.
Yes.
What is that? What is that common factor there?
2.
2.
4.
So 2. When you reduce it, what do you get? So therefore, our f g of x will be equals to
4.
will be equal 4
over x.
4 over x. Very good. A quick reminder, we have 10 minutes remaining. After 10 minutes, we shall take a break, okay?
Yes.
Yes, then we join back. Okay, but let's proceed. So, are we together, members?
Yes.
Yes.
All right. So our f g of x we have already got is what? Is 4 over?
X.
Is 4 over x. B. Let's go to B. Let's go to B. Let's go to B. Maybe before we go to B, can we add this question? Because I'm not seeing it there. Let's find f, g f of x. Let's first find that one before we proceed. Okay?
Yes.
Yes, so that we understand better now. So what will be our first step? So we shall have f, g f of x, which is going to be equals to g into f of x. Not so?
Yes.
So g into what is f of x? Our f of x is 8 over
8 over 4.
x minus 1. Not so?
Yes.
I said that one become a single what? Function of g. Are you together?
Yes. Yes.
So which means it implies now our f, g f of x will become what is our g of x? Our g of x is 2x plus 1. Not so?
Yes.
Which means where there is x, we shall replace it with what? We shall replace it with 8 over x minus 1, right?
Yes.
Which will become 2 into 8 over x minus 1. I think that. Then plus 1. Have you seen that?
Yes.
Yes.
Let's simplify that. Let's
Excuse me.
simplify that. So when you open that bracket, what do you get?
Yes.
What do you get when you open that bracket? Hmm? What do you get? 16. Good. 16 into x over, I mean,
2x.
It will be 16 also over into x minus 1 plus 1. Right?
Plus 1.
Not so?
Yeah. Yes.
Yes.
This one is the same as over what? Over 1. Are you seeing that? So what's the
Yes.
LCM? What's the LCM of x minus 1 and then 1?
X minus 1.
X minus 1.
X minus 1. So x minus 1 divided by x minus 1, what do you get?
1.
And
Times 16?
16.
16 plus x minus
16.
x minus 1 divided by 1
X minus 1.
times 1 x minus.
X minus 1.
Minus.
You are seeing it from the screen there, not so?
Yes.
Yes.
Can we simplify 16 minus 1?
15.
15.
15.
So we get 15 plus x over x minus 1. Not so?
Yes.
So therefore, our g f of x is equals to 15 plus x over x minus 1. Is it okay?
Yes.
Very good. Very good. Have you put it down? Put it down. Put it down and we proceed. Put it down and we proceed. Members, let me hope you are putting it down.
Yes.
Yes.
All right. Yes. Yes, members.
Yes, teacher.
Yes, teacher.
Are we through with that?
Yes.
Yes.
Yes, teacher.
Yes. Yes, teacher.
All right. So let's go back to our question now. That was just additional question I've added. Okay.
Yes.
Our B was, what is our B? What is our B? They want us to find
G squared.
g squared of x. They still remain g squared of x. Okay.
Yes.
That one is the same as the same as g of x. That's what instead is the same as like that, because g squared means we are multiplying g how many times? 2 times.
2 times.
So which means g squared of x is the same as g of g, g of x. Are you seeing that?
Yes.
So which means we know g of x is the same as g. We start with the one which is close to x, so it becomes g of x like that. Are you seeing that? Are you together?
Yes.
Yes.
But what is our g of x? Our g of x was 2x plus
2x plus 1.
2x
plus 1. Then again, you substitute the same function in the other function of g of x. Okay. Yes. So now, which means now we shall have our g of x. Our g of x will be equals to. What is our g of x? Is 2 into x plus 1 also. So it becomes now
Yes.
2. It becomes 2 into 2x plus 1.
Plus
Then
1.
plus 1.
Plus 1.
Are you together?
Yes.
Yes.
Open this bracket. Can we simplify this? This one will give us
4,
4x.
4x plus
2,
plus 2 plus
1.
plus 1.
Plus 1.
So we shall have 4x plus what?
3.
Plus 3.
3.
So that's our g squared of x. Okay? Yes?
Yes.
Are we together on that?
Yes.
All right. So we have 1 minute.
Yes.
We have 1 minute to go. Then we come back and then we look at C, D, and E. Okay?
Yes.
Yes. So
Yes, teacher.
in the remaining minutes, if there's any question, you can use it to ask me, please. In the remaining minutes. If there's any question, you can use it to ask me. Is everything clear?
yes.
Yes.
Are you sure, Olympia? Olympia, are you sure you have understood? Olympia, are you sure you have understood?
Yes, teacher.
Okay. What about Nalo Kenge?
Yes.
Opio Jacob, what about you? Are you okay?
Yes.
All right. What about Carol? Caroline, are we moving together, Caroline? Topista?